Welcome to our session. We are going to look at finance, and specifically, we're going to take ourselves through risk and return, one of the important topics that typifies the role of a financial manager, whose roles include financing decisions. So we are going to learn about calculating the expected return. So in our investment decisions, we underscored the fact that managers must involve themselves in allocating capital projects or firms to generate a future return. So the goal mainly for the shareholder is to maximize both by balancing risk and return. So these are key aspects that we're going to look at. What is expected return? It's simply the mean, the average return that an investor will anticipate from a security or a project. And what is risk or standard deviation? It is simply the measure of volatility of returns. If you have high volatility, there's high risk. And what is adjusted risk adjusted performance? We look at evaluating returns that are relative to the risk that has been taken. So we use what we call the coefficient of variation to compute that CV. So comparing firms, we're usually taught how to calculate the expected return for particular events. So we're going to look at this example in here from the exam where a farmer can grow maize and um, the farmer can grow maize and what? And cotton. So the following were the outcomes. We're being asked to calculate the expected return for each as well as the standard deviation for each. So the principle here is that if you have a higher standard deviation or if you have a higher CV, it simply denotes that there's higher risk involved in that particular investment. So we're going to calculate the expected return for maize, and you try to calculate the expected return for the other commodity. Expected return is giving us only 4 marks. So to find the expected return is simply multiply the probability by the respective return. So expected return is simply the mean. So expected return for cotton, simply the summation of the probabilities, PI at that point, times the return at that point. This simply means that you're just multiplying the probabilities as they are appearing. So 0.1 times the return on what? On cotton plus 0.6 times the return on the same cotton plus 0.4 times the return on the asset we are looking at. You do the same expected return for maize, ERM. We use the same formula here, 0.1. The probabilities are consistent throughout, times the return, 0.6 by the return. So you're seeing the way I'm getting the figures, I'm getting them right from the table as they are. So what are the returns for cotton? We use a different marker. We have 10%. Okay. So we start with cotton. We have 30, 20 minus 5. 30, 20 minus 5. Then here we have 18.7, and 7 and what? And 8%. So you compute that to calculate the expected return for each of those portfolios. So you're seeing we're just multiplying what? the respective probabilities with with the attached return. So if you have a calculator, you can calculate as they are appearing. Any questions so far? So the first one
No
for
questions.
cotton, 11%. Then for maize, we'll find 1.8%. So this is 11%, 1.8%. In terms of return, you say that which one has a higher return? Cotton. Then that is our 4 marks. Then the variance and standard deviation. How do you find the variance?
So when calculating the expected return, simply you multiply the probability times return.
To calculate the what? Yes, the probability times the return. So usually I like to use a table, which is very easy. So we have what? Probability of maize, 0.1, 0.5, and 0.4. 0. And 0.4. Okay, 0.1, 0.5, and 0.4. Okay, and the return for cotton was what? 30, 20%, and minus 5. And you multiply now here. What is 0.1 times 30? Here we have a 3. 0.5 times 20, here we have a what? 10. 0.5 times 5, here we have a what? A 2. So here this is probability times the return on cotton. So 3, 10, and minus what? 2. So when you add this, you're going to get 11, which we found here. Then we are going to now subtract from each of these return minus, this is our expected return. So the return in cotton minus the mean of cotton. The return, which is 11 minus 11, we start with 30 minus 11. What do we get?
Minus 11, that's 19.
19. Then you square the 19.
Vamos ver the calculator. Vamos ver the calculator. Done. Done.
Okay. So calculator there.
19.
So what did we
19
do after
squared.
finding the mean? 30 minus 11, 19. 19 squared.
19 squared. So minute. 361.
So 361, then you multiply the 361 to the probability of what? 0.1. What do we get? 36.1. So let's do the same with the second one here. What are you supposed to do?
So you You subtract 20, 11 from 20. Is it?
Subtract what? 11 from 20, correct. Mm-hmm.
That's 9.
Mm-hmm.
So 9 squared,
So
that's 81.
9. Uh-huh. And 81. Uh-huh. How do you do the 81?
81 by 0.5.
Mm-hmm. 40.5.
40.5.
Uh-huh. And here, minus 5, minus 11, minus 16. What do you do to the 16? Right.
You said minus 5, minus 5, minus 5, 11. That, isn't it?
Negative 5 minus 11 is what? Negative 16. Negative 16 squared is 256. 256 times 0.4
No.
is 102.4.
You said 256 by 0.4.
Yes, sorry.
Yeah, 102.4.
Mm-hmm. So plus, you now add these ones, 40.5 plus 36.1. So here you're going to have what? 179. The variance is 179, and the standard deviation is when you square root it. Square root of 179 is 13.38.
Mhm.
Then the CV is when you divide the standard deviation divided by the expected return. It's 1.22. So this has to be done with the same project, with the other project, and you compare which one has more risk. The higher the CV, the higher the risk. Okay. Daddy. Are you together? So here we want to compare. So the question is, find the expected return for cotton and maize. So I was just doing for cotton, we found 11. What is the variance for cotton? 179. What's the standard deviation for cotton? 13.5. Are you together? Have you
Yes, we're
followed?
following. Yes, yes.
Okay, so do I need to do the same for maize, or you get the logic in there? So you can do it in tabular form, or you can do it in analog form like I had started earlier on. So whatsoever is easy. I love the tabular. It's easy, okay, but also time consuming. I also love the normal way of doing it. So the normal way of doing it is just to attach the respective probabilities um, to the returns. So in the normal way for cotton, expected return is 0.1 times 30%. Okay, 0.5 times 20%. So this is how we get the 11. Then we do the same for B, 0.1 times 18, 0.5. So we get 18.5%. So this is how we find the expected return. All right. Then we go to our variance. For the variance, we said what? We get subtract for each of them the return, then you subtract the expected return from each of them. So since here we found 11%, you subtract from each of them. 30 minus 11% is 19%. Then you square it, we do this, and you multiply this by the probability. 0.1 times that. Then here, 20% minus 11% is square. You square it, 81. 81 from, you multiply by the probability, 0.5. Here, 5% minus 11% 16. 16 squared, we multiply by 0.5. So we found this. So when we total up, we find 13.38. Remember, right? You do the same
Yes.
case.
Yes.
So here, I'm just using the analog, okay, where you can avoid the tables if you want, but the principle is simply the same. So the return for maize, we had 18, 27, and 8. So you subtract the 18.5 from each of them and you square. Then multiply by the respective probabilities. Here is 0. What? 1. Here it is 0.5. And finally 0.4. So when you multiply each of these ones, you're going to find our total probability to be 80.25. Then you square root, we get what? 8.96. So which one is more risky? This is the standard deviation for maize, and for cotton, we found the standard deviation for cotton as 13.38. So which one has more volatility? The cotton. Okay. Then lastly, but not the least, the examiner now is asking us to calculate if we are told that the farmer grows 60% of the field with cotton and 40% with maize. What is the expected
Sorry,
return?
let me ask.
Uh-huh.
So the higher the standard deviation, the higher the standard deviation, the higher the fertility.
Yes, or the risk, yes. So a standard deviation is not
The risk.
not good. If you have a high standard deviation, meaning we're missing the point. For instance, like saying I am going to make it 10 million, but my level of doubt maybe is 60%. This one is saying I'm going to make it 10 uh, million, but my level of doubt is 10%. You'd rather go down who has a smaller deviation. All right. Are we together?
Yes, yes, yes.
All right. So we're now going to part C. So in part C, we must underscore the important information that we had initially. So we can tabulate the information to say we have what? Cotton, and we have maize, and we have expected returns for each of them, okay, and the weight for each of them, the standard deviation for each of them, and the variance for each of them. So the expected return that we found for cotton initially was how much? It was the expected return for cotton, do you remember? It was the 11% and 18.5%. We put here 11% and 18.5. So if the weight, how much was invested in cotton? 60% and 40% in maize. So cotton 0.6 and maize 0.4. Then the standard deviation we just calculated for okay. The standard deviation um for cotton was 13.38, whereas the variance was 179. 13.38, you put it here. and 179 was our variance. Then we went to our maze. The standard deviation was 8.96, and 80.25 was the variance. 8.96. 8.96. Six. Here's 80.25. So with this information, now we've been asked to calculate two important things. Number one, the expected return for the two portfolios. So this is a portfolio expected return. So the portfolio expected return, simply the return by the probabilities, by the weight. This is the probability. So 11%. What was the weight? The chance of getting this 11%? So 60% was in maize. And his expected return was what? 18.5%. What was the weight? 40%. So 0.4. So here, it's got the portfolio expected return 4 marks when you calculate it. So what do we get when you calculate the portfolio expected return? We get 14%. Okay, so this is simply found by the weight times so put your 14% there. Then we go to calculating what we call the portfolio standard deviation and variance.